Good day, everyone. The topic to be discussed today is the category process model. The learning outcomes are as follows. Let us first review some of the terms we have discussed in the previous lesson for this discussion. First, we have the process model. So, the process model provides stability, control, and organization to an activity that can, if left uncontrolled, become quite chaotic. The second is the software process. A software process is a coherent set of activities for specifying, designing, implementing, and testing software systems. And lastly, software process model. A software process model is an abstract representation of a process that presents a description of a process from some particular perspective. We now go to the different software process. We have four software process. First is specification. So when you say specification, specifications defining what the system should do. Second, we have design and implementation. Design and implementation defines the organization of the system and implementing the system itself. Third, we have validation. Validation is the checking if the software, uh what do you call this, meets the needs of the customers or of the customer. And fourth, we have evolution. So the evolution is the changing the system in response to changing customer needs. So the software should be evolving and adapting to the changes, okay, that is happening within a business or an organization. Let us now go to prescriptive process models. So, prescriptive process model, sometimes referred to as traditional process model. Prescriptive process model prescribes a set of process elements, framework activities, software engineering actions, tasks, work products, quality assurance, and change control mechanism for each product. In simple terms or simpler terms, prescriptive process models defines a distinct set of activities, actions, tasks, milestones, and work products that are required to engineer a high quality software. So these activities may be linear, incremental, or evolutionary. First, let us discuss the waterfall model. Now, waterfall model is an example of a linear activity. So, the waterfall model, sometimes called as the classic waterfall model, it was introduced by Winston W. Royce in 1970. In the waterfall model, once a phase of development is completed, the process proceeds to the next phase. Like, for example, if the communication activity is already finished, next will be planning. You cannot go back to communication. So, the waterfall model suggests a systematic, sequential approach to software development that begins with customer specification of requirements and progresses through planning, modeling, construction, and development, culminating in an ongoing support of the completed software. Now, the waterfall model is the oldest software lifecycle model and best understood by the upper management, of course. It is used when requirements are well understood and risk are low. Now, the waterfall model is also used often with a well-defined adaptations or enhancements to current software. So it's like a updating or upgrading an old version of a software. Now, there are some problems with the waterfall model. Like first, we have first problem. It doesn't support iteration or changes can cause confusion, of course. Second, we have difficulty for customers to state all requirements explicitly and upfront. So there might be changes, or sometimes the things that needed to be done has been forgotten. So there is a problem with going back to the previous task as suggested in the waterfall model. Third, we have requires customer patience because a working version of the program doesn't occur until the final phase is finished. And lastly, another problem with the waterfall model is that somewhat it can alleviate in the model through the addition of feedback loops. So that is why it is very important that everything was defined on all activities before proceeding to the next activity. The next is the incremental process model. So here is a paradigm of an incremental process model. Let me zoom in. So as you can see, there is an increment number one, increment number two, and increment number up to n. So there is a progression. That is why it is called the incremental process model. Now, the incremental process model is used when requirements are well understood. In incremental process model, multiple independent deliveries are identified. So, in every increment, something should be finished already or have been accomplished already. So this means that in every increment, a specific output also is identified. Workflow is in a linear or sequential fashion within an increment and is staggered between increments. Iterative in nature, okay, is one of the characteristics of incremental process model because it focuses on an operation product with each increment. Another is it provides a needed set of functionality sooner while delivering optional components later. And lastly, useful also. So the incremental process model is useful when staffing is too short for a full scale development. So development is through by phase. Okay. The next is the evolutionary process model. Now, the evolutionary process model is iterative. Okay, so they are characterized in a manner that enables you to develop increasingly more complete version of the software. Now, under the evolutionary model is prototyping. So here is a paradigm of the prototyping model. Now, the prototyping model follows an evolutionary and iterative approach. It is used when requirements are not well understood. Now, it serves as a mechanism for identifying software requirements. Now, the prototyping model focuses on those aspects of the software that are visible to the customer. Now, feedback is also used, okay, in prototyping model to refine the prototype. We now go to the spiral model. So here is the illustration of a spiral model. Now, the spiral model was invented by Dr. Harry Boehm in 1988. The spiral model is used when requirements are not well understood and risks are high. This is the opposite, okay, of the previous model that we have discussed. Now, inner spirals focus on identifying software requirements and project risk, may also incorporate prototyping. Let me show you the illustration there. Now, the outer spirals take on a classical waterfall approach. After requirements have been defined, but permit iterative growth of the software. Now, it operates as a risk driven model. A go on go decision occurs after each complete spiral in order to react to risk determinations. Now, the spiral model requires considerable expertise in risk assessments. Okay, so it serves as a realistic model for a large scale software development. Now we go to the concurrent model. Okay, now in this model, multiple phases are performed concurrently. So meaning simultaneous. Okay? So sometimes called concurrent engineering. Okay? So the concurrent model allows a software team to represent iterative and concurrent elements of any of the process models. Concurrent modeling is applicable to all types of software development and provides an accurate picture of the current state of project. Okay, so that is the concurrent, okay, model. Now, after learning the different models in prescriptive process model, let us now discuss the weakness or the weaknesses, okay, of evolutionary process model. So one of the weaknesses, okay, of the evolutionary process model is number one, prototyping poses a problem to project planning because of the uncertain number of iterations required to construct the product. So, the iterations are not well defined when using prototyping model. Okay, next, another weakness is evolutionary software processes do not establish the maximum speed of the evolution. So, if too fast, the process will fall into chaos. If too slow, productivity could be affected. So, it's a 50-50, okay, when it comes to evolutionary software processes. Okay, next we have another weakness is the software processes should focus first on flexibility and extensibility, and second on high quality. So we should prioritize the speed of the development over zero defects. Okay, and extending the development in order to reach higher quality could result in late delivery. So those are the uh, weaknesses, okay, of the evolutionary process. We now go to specialized process model. Okay, so the specialized process model takes on many of the characteristics of one or more of the traditional models. Okay, these models tend to be applied when a specialized or narrowly defined software engineering approach is chosen. Okay, so here are the different types of specialized process model. First, we have the component based development. Now, the component based development is consist of the following process steps. Okay? First, okay, we have one, two, three, four. We have five, okay, steps. Okay, first one is available component-based products are researched and evaluated for the application domain in question. Second, components integration issues are considered. Third, a software architecture is designed. Okay, so this is very important. Okay, to accommodate the components. Fourth, components are integrated into the architecture. And lastly, number five, okay, comprehensive testing is conducted to ensure proper functionality. So this is very important. Okay, now component-based development capitalizes on software reuse. So there is already an existing software, okay, which leads to documented savings in project cost and time. Okay. Now, second, we have the formal methods model. Okay. So the formal methods model, okay, encompasses a set of activities that leads to formal mathematical specifications of computer software. Okay, so it enables a software engineering to specify, develop, and verify a computer-based system by applying rigorous mathematical notations. Okay, now ambiguity. Okay, completeness and inconsistency can be discovered and corrected more easily through mathematical analysis using this model. So it also offers the promise of defect-free software. So imagine that, defect-free software. Okay, next and the last one is the aspect-oriented software development. Okay, so the aspect, okay, let me check here. So the aspect oriented software development, okay, referred to as aspect oriented programming or AOP. Okay, the AOP provides a process and methodological approach for defining, specifying, okay, designing and constructing aspects, mechanism beyond subroutines, and inheritance for localizing the expression of a cross-cutting concern. Okay, so that is aspect-oriented software development. Okay, now we go to the unified process model. Okay, as shown in the diagram, okay, you can see the unified process model. Okay, so the unified process model was birthed during the late 1980s and early 1990s when object-oriented programming languages were gaining widespread use. Now, some of these languages, object-oriented languages, you might have already learned, like C++, C Sharp, Python, PHP, Visual Basic .NET, JavaScript. So those are examples of a object-oriented programming languages. Okay. Now, many object-oriented analysis and design methods were proposed. Okay, three top authors, okay, were uh, in this method, okay, or proposing this kind of method. They are Grady Booch, Ivor Jacobson, and James Rambo. Okay, and this is the reason why eventually, okay, they work together on a unified model or method and was then called the Unified Modeling Language or the UML. Okay. Now, Booch, Jacobson, and Rambo later developed the unified process, which is a framework for object-oriented software engineering using UML. Okay. Now, in the unified process model, okay, it is consist of five phases. Okay. So, these are the five phases. Okay, we have the inception phase, okay, the elaboration phase, the construction phase, the transition phase, and lastly, the production phase. Okay, let me zoom in. Okay, now in the inception phase, okay, business requirements for the software are identified. So this is very important in order for the software engineer to meet the needs of the customer. So it encompasses both customer communication and planning activities of the generic process. Next, we have the elaboration phase. Okay. Now, the elaboration phase, okay, is a baseline that demonstrates the viability, okay, of the architecture, but does not provide all features and functions required to use the system. Okay. Now, it encompasses both the planning and modeling activities of the generic process. Okay. Next, we have the construction phase. Okay, let me move the screen. Okay, now the construction phase, okay, the construction phase is develop, okay, or develops or acquires the software components that make each use case operational. Okay, it encompasses construction activity of the generic process. Okay, the transition phase, okay, is next. Okay, now the transition phase is where software is given to end users for beta testing and user feedback reports on defects and necessary changes. So testing, okay, this phase is more of testing the software, okay, if it meets the needs, okay, of the client. Okay, and lastly, okay, we have the production phase. Okay, the production phase is the ongoing use of software monitored. Okay, so or monitoring the software. Okay, so it encompasses the last part of deployment activity of the generic process. And that concludes this lesson. Okay, thank you for listening.